Folks, let's get started. I appreciate you coming. It's 4 p.m. I know it's been a long day, first day, right? So we'll try not to bore you, but a little excite you. There is a story in front of us, which is migration story or maturity story to be presented. So it will be technical story, but again, not to bore you. Prepare your questions, and once again, it's a half an hour, a journey of people that run people mesh. You know, irony here, we'll talk about mesh, but technically, this gentleman named Suren, he's part of the company that actually runs people mesh. And it's not that loud sort of thing, but I'll let you start and talk about us through the journey, and then prep your questions, and we're here to stay until you stay to answer your questions. All right? So Suren, over to you.
All right, let's get started. Let's forget the tech for a moment and think about people. It's a Thursday evening, 6 p.m., busy time across Middle East. In Riyadh, a mother opens an app. She is trying to get a ride to get her child to hospital. It's an emergency. In Amman, a restaurant owner opens an app. She got all the ingredients stacked, stops ready. She is counting on those evening delivery orders to make her week. In Dubai, a driver starts his shift. He opens the same app and waiting for his first booking. He is working away from home, trying to earn enough to support his family. All of these moments, all of these human moments, depends on a single digital platform. For most of the apps, if they go down for 10 minutes, sure, maybe it's a bit annoying. But if this one goes down, it affects someone's ability to earn for the day, or it could delay someone getting to hospital on time, or it could mean something real. We are talking about Careem, the region's everything app. And we are here to talk about how Careem migrated to Istio without downtime using Gamma as a foundation. And my name is Suren Raju. I'm a staff site reliability engineer, part of traffic engineering team at Careem.
Sergey's here from Tetrate, doing some Istio from day to day.
Let me tell you a bit more about Careem and what drives everything we do. Have you ever been to Dubai, anyone? Okay, if you have been to Dubai before, I'm pretty sure you have used Careem app or at least seen Careem fleets around. For everybody else, Careem is everything app from the Middle East, helping millions of people get around, order food, groceries, manage payments, and all in one app. Careem's purpose is to simplify the lives of people and inspire people to achieve extraordinary things. Since 2012, Careem has created earning for more than 3.5 million captains. We call them captains, not drivers, because this work carries dignity. Every trip helps feed a family, pay school fees, and build a better future. And Careem has simplified more than 75 million customers across the region, and more than 10,000 restaurants partners depend on Careem to reach to their customers and serve them. And all of this happens in 70 cities across 10 countries, from Morocco across Middle East all the way to the Pakistan. Every market is different, but everywhere Careem's promise is same. Just with the click of a button, life gets simpler. And why we chose Istio? Careem started as a ride-hailing service in 2012, and over the years it grew into a super app. Careem is built on microservice-style architecture. Today, our infrastructure hosts around 700 active services in 5 EKS clusters across 2 AWS regions. Every interaction between our customers, captains, partners, and our services flows through what we call the traffic platform. And a busy day, our traffic platform processes about 1 billion public API requests and 5 billion internal API requests. As we grew, our traffic platform became fragmented. We had Linked as a service mesh, Kong as Ingress gateway, different technology for our API gateways. We even had few other proxy setups. None of them were bad individually. They are all great products, but together they created operational friction. First of all, it was challenging for us to implement consistent policies across these stacks. And our service owners needed more features from the traffic platform, but our current traffic platform was limiting us to deliver them. And our team had to learn and maintain these different stacks. And the upgrade cycles were longer because every stack needed their own testing and rollout process. So we had to redesign our traffic platform, and what we needed came down to 4 key things. First, we needed a single cohesive architecture, something that could handle ingress, egress, and service-to-service traffic seamlessly. Then we needed more features of the mesh. As we started operating services at scale in Kubernetes, new requirements started to emerge, such as rate limiting, concurrency control, and so on. Then we also wanted an extensible data plane to cater to Careem-specific use cases. Finally, we wanted our traffic platform to be built on something truly open source, widely adopted, and backed by a vibrant community. After evaluating multiple options, we chose Istio and Envoy as a unified tech stack for our traffic platform because it gave us everything we needed: consistent traffic management, proven reliability at scale, and a vibrant community that keeps innovating. Choosing Istio and Envoy was more than just a technical decision. It was part of our reliability promise to our customers, captains, and partners. Now, picture this. You are in Dubai, and you are ordering a signature dish from a popular restaurant for a friend's get-together, just right from Careem's app. But I will tell you something. Maybe it's a secret. To serve the food better and faster, the restaurant is upgrading its kitchen. But you don't need to worry. The same delicious food will be delivered to you on time. Coming back to reality, choosing Istio and Envoy was the easy part. However, the real challenge was to figure out how to migrate hundreds of products and services safely. So we needed a migration process that is fast, safe, and completely invisible to people who depend on us, the same way the restaurant is upgrading its kitchen while serving their customers. First, we needed the migration process to be fast. For that, we needed to minimize dependency on cross teams. To make the migration safe, initially we considered building a parallel Kubernetes cluster with Istio and gradually migrating services there. However, this was complex and requires effort from other teams to deploy Kubernetes clusters, build the cluster components, and monitor them. This was complex, and coordinating multiple teams would become a massive collaboration project. So instead, we had to find a way to do the migration in cluster. Then we needed the migration process to be fail-safe because every failure could mean something real to somebody. When you migrate a live service from Linkerd to Istio, there could be unknowns. There could be a connectivity issue, latency spike, or even difference in how data plane behaves between Linkerd and Istio. So we needed a process that makes a migration safe by gradually shifting the traffic, continuously monitoring for errors, and automatically rolling back if something went wrong. In simple terms, every service migration from Linkerd to Istio has to go through a canary process. At Careem, we run service mesh in a transparent way to our service owners. In most cases, our service owners do not even know there is a service mesh exists. So we had to design a migration process that is completely invisible for the service owners. Initially, we considered migrating all the services in a cluster in a single maintenance window, but this could make the rollbacks longer and increases the risk during peak hour. Instead, we decided to go with the gradual batch-by-batch migration, one cluster at a time, learning and improving as we go. So we would batch the services based on dependency and criticality and migrate them in low traffic hours between 3 a.m. to 6 a.m. local time, and there is no regular deployment from our service owners and minimal customer activity. And also we run the rollout across multiple days to gradually increase traffic to Istio control plane. So finally, to make the migration fast, safe, and completely invisible, we relied on 2 key ingredients: Gateway API for service mesh, Gamma, and Flagger. Let's take a closer look how they worked in practice. So what is Gamma? Gamma is a gateway API for mesh management and administration. In simple terms, it extends gateway API for service mesh use cases. In Careem, we already use gateway APIs with Linkerd. So we used the gateway API as a foundation to do the mesh migration. All right, so Let's look at how Flagger and Gateway API helped us to achieve invisible migration. Flagger automates the release process for Kubernetes workloads using a custom resource definition called Canary. At Careem, every service is deployed through a standard Helm chart and opinionated CI/CD pipeline. In the Helm chart, we use Flagger's Canary object to define the release process for our services. So when a new version of the application is deployed, for example, V2 is deployed, Flagger would gradually shift the traffic to Canary pods and does a Canary analysis based on traffic metrics. If the metrics looks fine, Flagger would promote the deployment. To adjust the traffic weights, Flagger creates additional customer resources based on the service mesh implementation. When Flagger is deployed with Gateway API as a mesh provider, it creates HTTP route objects automatically and progressively changes the weights in the HTTP route object. As HTTP route is a vendor-agnostic API and understood by both Linkerd and Istio, the underlying service mesh implementation takes care of actual traffic shifting. So we used this process to come up with the invisible migration. So basically, we get a live values from the cluster and patch them to enable Istio injection and disable Linkerd, and we would do a Helm upgrade, and rest is taken care by Flagger. So it enabled us to design a safe in-cluster migration using existing Canary rollout process without major changes to deployment scripts and also without requiring additional infrastructure. All right, so every week before we do the actual production migration, we would review the migration plan internally, and every single time the same question comes up: how confident are you? This question is real, right? Because at any given moment, there are so many people depend on Careem. So how did we build the confidence? And here's what we did. First, we set up all the prerequisites for the migration. We deployed Istio control plane in parallel to Linkerd and disabled mutual TLS. This allows traffic between Istio and Linkerd mesh services flow normally. And we used blue-green deployments for our ingress gateway. So we meshed non-live blue gateway with Istio and deployed a temporary load balancer in front of it. So at the time of migration, we had to create a service-specific DNS record to route the traffic through blue gateway, which is meshed with Istio. Then we focused on observability. We created unified dashboards combining Linkerd and Istio metrics. We also deployed purpose-built anomaly alerts on both mesh and ingress layers. And we also enabled Istio access logs to be able to troubleshoot any issues during migration. Then we focused on testing. We tested the rollbacks and deployments for different workload types and protocols. We also ran different connectivity tests, such as Linkerd to Istio, Istio to Linkerd, client traffic from inside the cluster, outside the cluster, and so on. And before the migration, we would dry run the batches that are selected for that week, just to ensure that automation works as expected. Coming back to the question of how confident are you, so we were able to show it with the data that we are confident, not just words. All right, you remember the order that you placed for the friends get-together? Now your order is being prepared in the kitchen. But behind the scenes, the restaurant is upgrading its kitchen just to serve the food better and faster next time. Let's talk about our kitchen upgrade, the service migration to Istio. The following process that we are going to discuss is completely automated and executed by traffic engineering team without service team's involvement. Let's walk through it with an example. Identity provider service. This service receives traffic from both ingress and mesh, and the release process for the service is defined through Flagger's Canary object, and Flagger manages the HTTP route object for the service. At the time of migration, the automation first creates a DNS record based on the ingress host names for the service. This allows traffic for the specific service to flow through the blue gateway meshed with Istio. Then automation triggers a deployment by enabling Istio injection and disabling Linkerd. With that, Flagger would kick in and start the Canary rollout process. The Canary pods start with Istio proxy attached. And Flagger updates the traffic weights in the HTTP route object. Since HTTP route object is vendor agnostic, understood by both Linkerd and Istio, the actual traffic shifts to canary pods. At the same time, Flagger does a canary analysis using Istio's traffic metrics. If the success rate and failures stay under defined threshold, canary progresses. At the end of the canary analysis, Flagger would promote the deployment, deployment meshed with Istio. At this time, the service is fully meshed with Istio. For whatever reason, if the canary analysis failed, Flagger would automatically roll back the deployment to its previous state, which is meshed with Linkerd, and Flagger marks the canary as failed. At this stage, the automation would delete the DNS record it created. This will allow the traffic to fall back to the green gateway meshed with Linkerd. This gives us a safe fallback and time to investigate the issue and retry the migration. At the end of the whole migration in a given cluster, all the services would have been migrated to Istio, including the blue and green gateways. We would have decommissioned the temporary load balancers that we created and also decommissioned Linkerd control plane safely. All right, so no matter what changes behind the scenes, your order gets delivered on time, and that is Careem's promise. The same way we kept our reliability promise to people who depend on us. We completed the migration without any downtime or without having a degraded experience to our customers, captains, and partners. It took us about 6 weeks to complete migration across 5 production clusters involving 700 active services, and we did that without any major rewrites to our deployment scripts or additional infrastructure. So Flagger's canary rollout process combined with Gateway API worked for us reliably from start to finish and making the migration completely safe and invisible to people who depend on us. I hope you don't mind if I join this friends get together and share some of the learnings that we had from this migration journey. Let's talk about the Gateway API and portability. Portability is one of the core design principles for the Gateway API. And in our migration journey, Gateway API simplified the migration as it gave us a standard way to handle traffic routing across service mesh providers. It fit perfectly into our ecosystem and helped us achieve zero downtime migration without major engineering effort. However, swapping service mesh implementation is not just about portable route configuration. You are swapping the whole data plane, and the data plane may handle things differently. In our migration journey, we came across few scenarios that required custom tweaks beyond standard HTTP routes. Let's walk through it with some examples. One of the issues that we encountered during service migration to Istio was canary failures due to high latency. When we looked closer, the issue was not with Istio, but the difference in how latency was measured. Linkerd measures the latency up to the first byte. Istio measures the latency, like total response time. So once we understood the difference, we adjusted the canary thresholds and reran the migration, and everything worked fine. Another issue that we encountered during migration was canary failures due to 502 errors. So this happened for our Java services when they returned duplicate transfer encoding headers in the response, and Istio rejects those requests, and which used to work just fine in the Linkerd. So this happens when the Java service receives the request, forwards it to an upstream, and gets the response entity and returns the same response entity. So the fix was simple. Instead of returning the same response entity, you would create a new response entity and return the new object that you created. Beyond this, we also had few other scenarios that required Istio-specific tweaking, such as failures connecting to external proxies, broken URL redirections, connectivity issues during application startup and shutdown sequence. I kept the configurations that we used to fix these problems in the back of the slide. If someone interested can refer that. So the key takeaway here is having portable route configurations does not always guarantee runtime parity. If you are planning to swap service mesh implementation using Gateway API as a foundation, you need to be mindful about runtime issues. Let's now talk about the Gateway API and ecosystem. In our experience, what we have seen is that the specification is evolving fast, but ecosystem is taking a bit longer to catch up. In our journey, we came across 4 different Gateway API implementation, and all of them were supporting different versions of the specification. To give you an example, at the time of migration, the version of Linkerd that we used did not support timeouts in the HTTP routes, but Istio supported it. We also encountered another issue, which is inconsistency between implementations, especially between Linkerd and Istio. As per the Gamma specification, the HTTP routes would not infer any functionality from host names. However, Linkerd enforced it, Istio completely ignored it. So this created some kind of confusion for us. To summarize, Gateway API is a great foundation, but the ecosystem is still evolving. As ecosystem continues to mature, I think the support is going to get better. And beyond portable route configurations and the service migration itself, we had a lot of things to do. First of all, it took us a lot of effort in planning, testing, and then execution to make the migration actually work. Then it was significant effort to get mesh observability right, wiring right metrics, developing dashboards and fine-tuning alerts and so on. And post-migration, we start to see new challenges. Occasionally, our Istio proxy gets OAM killed when there is a surge in traffic or connections. So we had to continue investing our efforts in things like service mesh reliability. So the takeaway here is you will have a lot to do beyond the actual migration itself. OK, did we achieve all the things that we wanted from this migration? Yes, we got more features in the mesh. We have extensible data plane, open source community that keeps innovating. On the architecture and the reliability side, yes, we completed the migration without downtime. We have Istio and Envoy as a foundation, but we still have a lot of things to do. Right now, we are focused on solving reliability issues, such as optimizing our control plane configurations to handle out-of-memory issues, developing safe upgrade processes, and so on. And also, we have our gateways to be migrated to Istio Gateway and Envoy Gateway. Yeah, so throughout the migration journey, we learned a lot, and we hope some of this learnings helps others in the community. And that's our journey of how Careem migrated to Istio while keeping Careem's reliability promise. And thank you all for listening.
Right.
I hope we have some time for the Q&A.
Yeah, feel free to come in and ask the questions, so we can address the questions right now. But basically, the long story short is Suren and Careem team migrated to Istio. It actually opened a new set of the challenges that they have to address, because technically, as you migrate over, right, you onboard a new technology that will have their own burden in a way that you have to respect, right? So it means even though the gateway APIs and things allow you to quickly move in, there's a lot of things that you have to consider in the planning phase, as well as you move in. As you can see, the system will react differently to the load and stuff. So basically, there is that continuous improvement loop has to be established. But in the same time, the team not just established the migration procedure, they also established the upgrade procedure, as they'll be moving on from the revision to revision, from Istio to Envoy Gateway. Basically, they have the bits that they established that are reusable. So it's not necessary from A to B one way, and we forget about those procedures. But basically, that's the procedures that got established to enable them to fuse and move in from, let's say, revision A to revision B, or from Istio to Envoy Gateway for north-south use cases. And I want to highlight, the team is handling 1 billion transactions a day in northbound direction and the 5 billion in the mesh. So it's like, it's quite enormous traffic to handle from the point of the user application traffic, right, not the backend. All right, any questions?
Yeah, mid-migration, what did it look like when you had like maybe half your services are already on Istio and half are still in Linkerd? How does the mesh work when only one mesh is only aware of half of them, the other mesh is aware of half of them? What did you use to solve that complexity?
In the prerequisite, we disabled mutual TLS enforcement, so that allowed the traffic between Istio and Linkerd mesh services to talk to each other safely. During the transition period, we did not have mutual TLS enforcement. That is something we could afford, so we went with that. Thank
Hi, my question is, when you migrated to Istio, did you also migrate with their ingress and egress into the cluster, the ingress gateway, egress gateway, or is that out of scope for your migration, and you have like a different solution for getting traffic into and out of the cluster?
So in the initial migration, we did not consider the gateway. We still, as we speak, we are migrating the ingress gateway as well. We thought like we will do it one step at a time. First, we completed the migration, the service mesh migration. Now we are also migrating the gateways to Istio gateway. And the process that we developed helped us to migrate now the ingress as well.
Thank you.
So the bottom line, the HTTP routes that established, they apply for both for north, south, and east, west. So basically, the process is unified, right? It's basically where that attachment point is. That's sort of the beauty of that thing. But in the same time, the team is also considering for the north, south to move in also to Envoy gateway. So basically, there will be. But again, there's a HTTP route that is in place to handle it. So basically, your Flux Canary thing that there was a. If you've seen it, there was actually quite powerful slide that was showing the canary object, and then after it, there was a showing the HTTP route that generated. That basically behind the scene, that's it, and the metrics that being overlaid. So basically, it applies for north, south, and east, west.
Yeah. Hi, my question is around Flagger canaries. Do the canaries scale up corresponding to the percentage of traffic, or are you forced to basically run a double deployment throughout?
No, not double deployment. So we were able to do the migration within existing deployment. If you already worked with the Flagger, during canary analysis, right, it creates another deployment, which is canary. So only during the deployment, there will be like two deployments. But that was part of our canary rollout process, nothing specific for the migration. So we made use of the existing deployment process.
Right, yeah, and like during that deployment process, are both of them running at full scale?
Yes.
Or is one like at 10% scale and 50% scale? And
no, in Flagger, let's say if the primary deployment, let's say you configured 5 as a replica.
Yeah.
When the canary pods comes up, it's equal number of replicas. So Flagger does it like that. Yeah.
Thank you.
I mean, maybe something worth to call out. The average migration time, the average canary bootstrap was 3 minutes. So basically, it wasn't like 20 minutes for map time. Yes, there was a duplication of resources concern, but it was like for the shorter period of time. It wasn't 20 minutes, it was 3 to 5 minutes time frame. But yeah, it's a classic 2 deployments, 3 services, key service, primary service, canary service. So it's a per book Flagger deployment. So yeah.
Thank you.
Yeah, you're welcome.
All right. Thank you, everybody, for listening.